Hello friends, welcome back to We Student Blog. In this series of DevOps training, we'll be looking at introduction to core concepts of DevOps. So in our previous video, we was discussing about we came to know what is DevOps, what is the role of DevOps engineer, what are the advantages of using DevOps, and what all issues can be resolved if we go for DevOps. So as I said for a couple of videos, this will be completely theoretical. So I know this is a brain bone crushing, but we have to go through it to to make ourselves perfect, to understand the concepts, all stuff. So this is about introduction to core concepts. So DevOps engineer implements CDCI pipeline. So we in the previous video also we were discussing, like you took the name called pipeline couple of times. So CDCI is nothing but continuous integration and continuous delivery. So it automates software builds and deployment routines, and manage either on-prem or cloud infrastructure. So it means that when a developer he makes ready some code, so code, or he writes a code and he share that code with you, with a DevOps engineer. So his role is to deploy it, then package, you call package. So he has to package it, and then he has to deliver it to he has to deliver it to the dev environment, or whatever the DevOps engineer, like a developer, requests him. So that package will be installed on servers. Okay, it's not like it won't be going to anywhere. So it we will discuss more, like what exactly we want going forward. We'll look at each and everything. So initially it will be a little bit confusing, but if you follow the training sessions, then you will understand everything. So let me read it one more time. DevOps engineer implement CI/CD process, automate software built and deployment routines, and manage either on-prem or cloud infrastructure. So what is this on-premise, or we call on-prem also? On-premise or cloud infrastructure is, on-premise is nothing but your own data center, your own servers. So companies will have their own data center, their own servers. That is called on-premise. And cloud is nothing but cloud, Azure cloud, or AWS cloud, or Google cloud, or Ali cloud, any cloud which so we'll be discussing, and we'll learn what is cloud, what is on-prem in upcoming videos. So before that, what is this CDCI? We'll discuss about it. So CI/CD is a backbone of the DevOps. It's obviously, so the tools on each level or each place, we'll be using multiple tools. So we'll discuss in upcoming screens or upcoming PowerPoint presentation. So we'll first of all, what is a CI and CD? So CI is continuous integration. Continuous integration, or CI, is a software development practice in which developers integrate source code changes into the shared repository as early and often as possible, ideally several times a day. So each source code integration involves an automated process of building, testing, and verification of the code changes. Continuous integration allows developers to locate and eliminate software defects at the early stage of software development, thus dramatically accelerating the development speed. It means shared repository is nothing but, for example, if you take some website, Amazon, or any airline site, or any site. So for that site, if you see, there is something, when you log into that, when you open that site, you'll be seeing that the products displaying their names, their price, pictures, everything. So for that, a developer will write a code for that. Okay, So it's not one developer will do, hundreds, thousands of people will be working. A development team will have tons of people working on that. So they should store that all, like for example, uh, each developer will be given a task to do some activity. So all like for example, four developers are there, they will develop four codes, multiple codes for to create a website, and they will put all together in a place. Or maybe it's a code where multiple people work on that. So if a file is opened by for example, a file is copied to a place, and if somebody write on that, what happens, it will overwrite. It should not be like that. So for that, shared repository will be there where everyone will store their code there. And that shared repository, as a developers or even DevOps engineers, will be using GitHub. And we have multiple shared repositories like that. We'll be discussing on that, but one is GitHub, where we will be like DevOps engineers or developers will save their code there. So that is what we are discussing. So, and next is continuous delivery. So continuous delivery, or CD, is a further extension of continuous integration, in which software is released to the ready to release to the production at any time. Apart from the automated build and test steps of the continuous integration, the continuous delivery also includes fully automated release deployment, thus speeding up the development process even more. So that is what we are discussing. So delivery is also, continuous delivery is also important. So for example, if you see in the companies where you work, sometimes you'll be seeing our timesheet application will be down this night for a maintenance, or you'll be seeing that type of mails when in your work environment, or your salaries website will be down from this time to this time. So if you use the CDCI DevOps things, what happens is you won't see that happen, because without any downtime we can deploy the new upgrades or new deployments. Like if you see here, did you ever see in Facebook or Amazon saying that this website will be down for this time? Did we never see that? Because they will they will use this type of technologies, so that not even a single minute they will go down, or there won't be any maintenance. So maybe due to some network internet issues, or maybe that will go down, but website never goes down or application goes down. So next is continuous deployment. So continuous deployment, also known as CD. So it is is the superlative form of software development practice. It extends the principle of continuous integration and continuous delivery to the extreme. The software isn't just ready to release to production at any time. As in continuous delivery, it actually being released as soon as any changes is produced by the developer, usually multiple times per day. So continuous deployment is like whenever a code change is required, they will do it, and it will be done multiple times a day, and it will be delivered to that wherever required. So so that is called continuous deployment. And no one knows the changes, for example, you may see a product, for example, at the time of Thanksgiving Day uh, or Christmas Day, you may see an offer like an Apple Watch or some mobile. Uh, it will be given a discount of some 40% or 20% on particular day. So next day when you check, it will be won't be there, because the next day the developer will deploy the code, roll back the code to the normal price. So these are all the changes will happen, and you never know when it was happened. So when you refresh it, it will be changed. So this is some theory about CI and CD. So continuous integration, continuous delivery, continuous deployment. This is called CDCI pipeline. So a little bit about CI and CD, continuous integration. If you see here, build, then automated testing, all stuff we'll discuss about little bit more. So continuous delivery, like you see here, a build is like delivered, and that automated testing happen, deployed to staging, like a stage, like a stage environment, so everything works fine there. Then it will be deployed to the production. So here, if you see here, a continuous deployment, delivery is like it will continuously happen, and continuous deployment is also it's automated, and using some tools, a build is ready, then it will be tested, then it will be deployed to the stage or dev or test environment, and everything is correct, so it will be pushed to the production. So do we really do manually? Means no, we use lot of tools, Selenium or a lot of tools for testing, and that testing itself will fix the codes, or it will return the it will give the uh, code errors, and that will be sent back to the developer, and it will be fixed, and it will be automated to deploy to the production. So next is like TDD and microservices. This is called the development side of DevOps. So TDD is a test driven deployment. So what is TDD? Test driven deployment is a software development practice that requires software engineers to write automated tests before they even write the actual code, and that will be verified by the tests. With the TDD, software engineer follows a short development cycle, which write an initial failing automated test case that serves as a specification, ensure the test fails, write the minimum amount of code required to pass the test, then refactor the code, repeat the cycle. So the TDD dynamically reduces the risk of software bugs associated with each individual release. That makes it possible to confidently release product quickly and often. So it's like eradicating the error codes. So if some code is there which it's went to the production with an error, when a user opens a website with when he saw that code, error code, and that site is not working, then it will be an definitely it will be a problem. So that is we can eradicate before going to the production. So next is microservices. What is this microservices? So if you see here, microservices are an architectural approach in software development. They structure complex application as a collection of small, loosely coupled services. Unlike the more traditional monolithic architectural approach, microservices allows for the development of large, complex applications by small, autonomous teams following the two pizza rule. So microservices and the developers perfectly uh, complement each other, because it is much easier to build a continuous delivery pipeline for independently developed, tested, and deployed microservices than to configure a continuous delivery pipeline for a large monolith with one stroke. More often, small independent teams can deliver faster and be more agile than their larger counterparts. So microservices comes, for example, if you see Docker uses the containers where these microservices will be multiple microservices runs on Docker containers. So if you see this diagram where this is a bare metal server with a operating system on that, an application is installed, and that is that will be published. So for here, so you are able to see only one server with one application, but if you see microservices, it's like one server with OS, bare metal server with OS. On that OS we can build multiple microservices. For example, if you guys know about VMware, so VMware is nothing but we will discuss about a little bit more in upcoming videos. So I will give overview like physical server is nothing but a server which will, it's a hardware, okay. It will have a motherboard, a memory, everything. So like 15 to 20, 30 years back, one server is used for only one application. So if that server goes down, the application will also goes down, and entire resources on that such server will be used for an application which really does not use that complete resources. For example, that CPU is having 8 cores, and 8 out of that 8 cores maybe it is using one core, because remaining all cores are like they are idle and they are not in use. Until and then there is a huge hit happens from the end users. So memory also, out of for example it is having 64 GB, so the application does not use entire memory, okay. That will use up to 10% or 30%, 40%. So remaining all is not used, and it's like wastage of resources. So once the VMware came into picture, like what happened was that physical box, physical server, on that physical server, a hypervisor will be built. On that hypervisor, we can build multiple virtual machines with multiple operating systems. Each virtual machine will have an operating system. On that we can build a application. Like that, previously we used one server for one application, but based on the hardware, using the hypervisor, one server, on the one server we can build up to n number of servers, and n number of virtual machines. So like you can build 150 based on the hardware, and each virtual machine will be used for multiple applications. So like that, we can use the shared resources on that server. So I will give overview on, will briefly discuss on that technologies in upcoming videos. So microservices are the next level for the virtual machines. So microservice does not use the like virtual machine will use operating system, drivers, everything, but microservices doesn't, not even take that also. They won't use any operating system. They will be running on on a what do you call, one operating one virtual machine. On that multiple microservices will run. So if you see here, microservices can be run on a standalone server or a virtual machine or a container. Container is nothing but Docker containers. So even they can be run on public cloud. So we can it's called some new technologies, and using the resources more. So and we can publish our applications. So this is the like monolithic architecture, and this is Microsoft's architecture. So so most of the DevOps like going forward will be using the microservices. If you see here, like IaaS, like infrastructure as service, PaaS, software as developers, software as service, and SaaS, like platform as service, and this is the software service. If you see here, these are all like some differentiation, where like here in this layer, like you're able to see Azure virtual machines, or Google Cloud Compute, AWS EC2. Whereas if you see at PaaS, software developers, like AWS Lambda or Google App Engine, Azure App Services, and a SaaS like a Gmail, like these are all software as service, Gmail, Jira, Salesforce. So these are all microservices runs. Okay, so these some examples of this thing. So we'll, if you talk about IaaS, like if you see here, what is that? So infrastructure as a service. Okay, infrastructure as service, or IaaS, is the delivery of computing resources such as data, like data stores, network, virtual and physical computers to end users via service mode. An example of for IaaS is we discussed already, like Amazon EC2, Google, what do you call, Google Compute Engine, Azure virtual machines. So here, if you see here, this is what we are saying. So PaaS, platform as service. So platform as service takes IaaS one step further. So instead of provisioning and managing low level blocks of the underlying infrastructure, PaaS allows customers to deploy and run applications on the managed platforms. PaaS completely eliminates system administrative tasks such as configuration management, means patching or capacity management, like increasing memory, decreasing memory, downtimes for the physical boxes, all stuff comes into that. Software upgrades like patching or any application upgrades, and even security hardening, and allowing users to solely on software development. So examples already we are seeing here. So whether we can consider the example of PaaS, and talking about the SaaS, software as service, is a method of software product delivery to end users over the internet and via pay as you go pricing, in which the software is centrally hosted and managed by the service provider. So we were discussing this. So we don't do anything, only we'll pay for what we use. Okay. So unlike AAS, IaaS or PaaS, so SaaS is completely software product available to end user. So like even like Gmail, or what is that, Office 365, which we don't do anything. For example, if a extend server on-prem is there, you need to take care of everything, the server, hardware, upgrades, even your extend server upgrades, cumulative updates, also you have to take care. But if you go for an SAS, service, software as service, you go for Office 364, only you will manage like creating mailbox or users, all stuff, but the remaining all will be back end taken care by Azure. So next is this was already we discussed, but we'll this is what, see, this is on-prem, we discussed about IaaS, PaaS and SAS. So here we are able to see the colors, okay, dark blue and sky blue. So dark blue is user managed, means if you go to on-prem is nothing but your own data center which have servers. Okay, the servers, networking, storage, operating system, virtualization, other application, runtime data, everything has to be managed by the by yourself, means the system admins. Like server memory dim got bad, then it's your responsibility to replace it. Storage is full, then it's your responsibility to add the storage. Network, switches upgrades, even replacing the switches, and virtualization upgrades, operating system, everything has to be taken care by yourself. If you go to IaaS, infrastructure as services, so all so which are in sky blue, this will be taken care by the service provider. You don't need to worry about servers, storage, network, virtualization. Only the part is like operating system, middleware, runtime, data, applications, these are all has to be taken care by yourself. A virtual machine on Azure cloud, that is an example. PaaS, PaaS as a platform of service, is also like all the sky blue color, or they will be taken care by the service provider. Only the data and application will be taken care by yourself. Okay. And SAS we already discussed, everything will be taken care by the provider. Only thing is you will manage your like creating users, creating mailbox, such type of things you will be taken care by yourself. Even database servers, in this you will select the database, and you will work on it. But whereas SaaS, everything will be provided by the provider. Okay. So this is this, like if you Google also, you will get it, this what is called this screen. You will get more information on that if you want to go and read that. So what are the what all come in essays, like in this session, in this screen we share like what comes here. We have mentioned very few, but if you Google you will get tons. Okay. tons of applications. Okay, so coming to the like we discussed about containers, Docker containers, and so what is Docker, what is Kubernetes. We'll going forward, we'll be in this video I'll give an overview, but when you learn Docker and Kubernetes in our upcoming videos, we'll discuss theoretically as well as we'll do practically. So Docker containers and Kubernetes. Okay, so Docker container. What is Docker container? A container is a software package that bundles the application source code and all required software dependencies into one unit, ready to be immediately deployed in any environment. Docker technology relies on OS level virtualization, in which container shares the same operating system kernel. Docker containers are similar to traditional virtual machines. So unlike virtual machines, containers induce much smaller performance overhead, thus offering greater efficiency. So containers, like as we discussed, they will be sharing the same operating system kernel, but they don't require a separate operating system. Like a virtual machine, it will run on a hypervisor, like a bare metal operating system, but it will have its own operating system, own drivers, all stuff. But that will consume for own operating system. The operating system will consume memory and CPU, and on that, if you install some application will also consume memory and CPU. But in the containers, it's not like that. It will share the same operating system with other containers, and containers doesn't require operating systems, their own operating system, so they will just share the operating system kernel, and due to this, the consumption of memory utilization for separate operating system will be reduced. So that is the advantage, and they are same like traditional virtual machines. So Kubernetes, what is that? Okay, so Kubernetes is also an open source system for automating the management of containerized applications. So the Kubernetes project was announced in middle 2014, I believe, by Google programmers, and it is heavily based on Google's internal project called customer what is it cluster management system called Brogue. Okay, so so this was like this was developed by Google, and so this is somewhat like if you see, like for virtual machines in VMware, we'll have an VMware vSphere vCenter. Okay, using that we'll manage VMs, ESXi boxes, network, everything. Same like that, Kubernetes is used. It's not equal, but it's I'm just comparing. Like Kubernetes is a centralized management for applications, automating the management of centralized applications. We'll be using Kubernetes, and it's a free tool. Okay, so infrastructure as code, the confluence of dev and operations. So infrastructure as code means IAC. Infrastructure code is the infrastructure management approach in which infrastructure resources like networks, servers, and provisioned and managed using machine readable definition files. Okay, so this is about little about the core components of DevOps. So we'll end up for now. I hope this video is informative. I know this is theory and boring, but you have to know the core concepts, then only you will be good when you learn and work on the things, work on the upcoming tools and all stuff. So I hope this video is informative. In our next video we'll look into the like what is server, all stuff. Hope this video is informative. Thanks for watching. Please do subscribe and like my videos, and always any queries or suggestions, reach out to me on vstudentblog@gmail.com. Thank you. Bye bye.